G'day. As promised, we'll do some examples about the chain rule. I know you've been waiting desperately for some examples. You're sitting there going, man, I can't think of anything I would like more to be doing than doing some examples of the chain rule. I like your attitude. Okay, let's get started. So, the chain rule says for a function f of x, let's say f of x is equal to 2x plus 3 to the power of 2, we can rewrite this as equals y of u of x, where y is some function of u and u is some function of x. Well, then in that case, we have that f prime of x is equal to y prime of u of x times u prime of x. Well, what's a sensible function for u? Let's let u of x equal 2x plus 3, and let's let y of u be equal to u squared. Then according to this, according to the chain rule, because we can clearly see that f of x is equal to y of u of x, because y of u is u squared, and then u squared is 2x plus 3 squared, because u is equal to 2x plus 3. So we can clearly see that our conditions are met. So according to the chain rule, f prime of x is equal to y prime of u, so 2u, times u prime of x, or u prime of x is just 2. So that's equal to 4u. Oh, but I got that wrong. It says it's equal to y prime of u of x. And, well, it's the same thing, but basically, oops. What happened there? Oh yeah, 4u. It's basically saying that because our original function started with x, we should probably present the answer in terms of x as well. And so this is equal to 4 times 2x plus 3, which is equal to 8x plus 12. Now you may be sitting there going, geez, Nick, why do we even need this chain rule? This is dumb, because I can just expand f of x out. I can expand these brackets. If I expand the brackets, clearly f of x is equal to 4 times x squared, because 2x times 2x is 4x squared, plus 2 times 2 times 3x, so plus 6x. Wait, what? Plus 2 times 2 times 3. Have I made a mistake here? No, plus 2 times 2 times... Yeah, plus 2 times 2 times 3. Plus 2 times 2 times 3. 2 times 3 is 6. 2 times 2 times 3 is 12. Thought I was going insane there for a second. So 4x squared plus 12x plus 3 times 3 is 9. So that's true, yep. F of x has to be equal to that. And so now we can differentiate it as f prime of x equals... We bring the 2 down, as usual, using our power rule from the section about differentiation. So it's equal to 2 times 4x, so 8x, plus, and now this is x to the power 1. We bring the 1 down, and then x to the power 0 is just 1 anyway. So that's equal to 8x plus 12. And, of course, this 9 is the same as 9x to the power 0. We bring the 0 down, and then it just vanishes anyway, because 0 times anything is 0. So, yes, you could do it that way. That's all fine. We get the same answer. There's no issue there. However, suppose I then turn around and say, well, okay, Mr. Smarty Pants, how about f of x equals 7x plus 12 to the power of 100? Expand that one. And let's just divide it by 2 as well for fun. Well, I don't think anyone wants to sit there expanding 100 pairs of brackets all day. So let's use the chain rule, just the chain rule for this one. So a sensible function for u, of x, let's let u of x equals 7x plus 12. That's all well and good. So u of x equals 7x plus 12. Then that must mean that y of u, because remember, we want y of u of x to equal f of x. So that must mean that y of u is equal to u to the power of 100 divided by 2. This is kind of, at the moment, this is kind of like the outside function, and this is the thing that goes inside the outside function. So that's another way to visualize it if you're kind of getting stuck with this. Okay, so y of u equals u to the 100 divided by 2, and u of x is equal to 7x plus 12, and we have that f of x is equal to y of u of x, and therefore f prime of x, f differentiated at the point x, is equal to y prime of u of x times u prime of x. Well, u prime of x is just 7. I can clearly see that because, well, just look at it. It's a line. It has a gradient of 7. So u prime of x, shouldn't write it like that. It looks like I'm dividing by 7. U prime of x is equal to 7. Now I just need to find y prime of u of x. Well, y prime of u is 100 divided by 2 times u to the power of 99. So 50 u to the power of 99. Oops. Because remember, we're dividing the 100 by 2 on the bottom there. So it's 100 divided by 2 times u to the power of 99. So 50 u to the power of 99. And we should present it in terms of x because our original function was presented in terms of x. And so this is equal to 7 times 50 times u to the power of 9. Well, 7 times 50 is 350 because 7 times 5 is 35. So that's equal to 350 times u, which is 7x plus 12, to the power of 99. And I think that makes life much easier. So f prime of x is equal to 350 times 7x plus 12 to the power of 99. So the chain rule comes in particularly handy when you got huge powers on top like that, because you know nobody wants to expand all that up. All right, we'll do one more example just to really get the hang of this thing. So final example, let's take f of x equals 3 plus 2x to the power of 4 divided by 2 plus 7 times 3 plus 2x squared plus 3 plus 2x. Plus 3 plus 2x. Okay, that's all well and good. So what's a sensible function for u? Well, let's take this guy right here, because if we let that equal to u, then we got a polynomial, and that's nice and easy to deal with. So u of x is equal to 3 plus 2x, and of course y of u therefore must be equal to u to the power of 4 divided by 2 plus 7u squared plus u. And then we know that we got to differentiate this one, and then multiply them together. And that's going to be f prime of x. So f prime of x is equal to y prime of u. Well, y prime of u, we'll bring the 4 down. It's going to be 4 divided by 2 times u to the power of 3. So 4 divided by 2 is 2. So 2u cubed. If you didn't hear in the last video, there's that u cubed again. When I was teaching in China, I was doing some math problem on the board, and then I was like, see, here's a u cubed, and then this kid stops. He's like, no, sir, you're cute. That one got me. Gets me every time I see u cubed. Okay, anyway, 2u cubed plus 7 times 2, u to the power of 1. So 14u plus 1. So u differentiates to 1. Okay, well that's the y prime of u times u prime of x. So times u prime of x. Well, u prime of x is just 2, because we've only got one part of it even dealing with the x variable. Okay, so f prime of x is equal to this thing times 2. Well, that's equal to 4 times u cubed, while u is equal to 2x plus 3. So 4 times 2x plus 3 cubed plus 14 times 2, which is 28 times u, which is 2x plus 3, plus 1 times 2, so plus 2. Okay, so yeah, that's one way to do this. I now realize that yeah, you can actually just treat each of these separately anyway, so you don't have to make as big of a deal of it as what I made just then, because differentiation ignores addition. So actually, you can just differentiate each of those separately in the same way we were doing before. But hey, it's nice to know that this thing still works out nicely. All right. You can do it in that way now, actually, as an exercise if you want, and check that I did everything right. Maybe I screwed something up. It happens. Okay, thanks very much for watching. Don't forget to check out the notes about chain rule and do those exercises at the back. The only way to learn maths is by doing maths. If you just sit there and pore over the notes and watch the videos without actually trying anything out yourself, you're not going to learn it very well. So make sure you do the exercises. Really important. Okay, thanks very much. See you next time. Bye.